Materials play a huge role in how we perceive architecture. They add color and texture to the image, they decorate the space. If you want to achieve great results in 3D, you have to first be a great observer of the surrounding world. To understand how the materials work in 3D, you have to first understand what are their characteristics in real life. To do so, practice by asking yourself the questions. What kind of material is it? Fabric, stone, wood? Is the base color uniform or has a pattern? Does the material have any reflections? Are the reflections smooth or matte? Is the material solid or transparent? How sharp are the reflections? Are they clear or blurry? Do the materials have any roughness or irregularities? If you know the answers to these questions, you will know what to do in 3D software. Let me explain to you how it works in 3ds Max and Corona. I have a simple scene here with some sculptures, so we can easily see how the material is changing. To turn on the material editor, use the M shortcut. For your own tests, you can use the simple teapot, for example. Anyway, on the left-hand side of the material editor, we have materials listed. You can find all the materials from 3ds Max and Corona here. They are logically categorized. The basic material you will use will be Corona physical material, which you can find here. You can drag and drop the material from here. Or you can right-click on the view area and choose the proper material from here. In the previous versions of the Corona, we had a different material, and for some time, it's called Corona Legacy material. You may see this material, for example, when you import models that were created before Corona Renderer 7. But let's focus on the Corona physical material. First of all, we can choose the basic materials from the presets. So we don't have to actually know anything, and we can apply some basic materials in the scene. Sounds good, isn't it? Anyway, I applied the material to the objects and start interactive rendering so we can see what is going on. Let's choose brushed aluminum, for instance. Or brass foil. We can choose glass. Or some plastic. I encourage you to check out all of these materials by yourself. We can adjust the materials to our needs. We can, for instance, change the color of the plastic or change parameters. But let's go back to the beginning. I reset the material and we'll start from scratch. First of all, metalness. We can choose if the material is non-metal or metal. We can start with metal first. So we have this base layer panel. We have level and color here. Color in metal materials defines the color of reflections. So we can make them darker or brighter. We cannot see sharp reflections because we have a roughness value set up to 0.75, which means that our reflections are quite blurred. In general, roughness controls the smoothness of the base layer surface. The value 0 gives a completely smooth surface, which gives sharp reflections. So now, we can change the color of reflections so we can see how it works. Now, more towards the value 1, we create a rougher surface that causes more blurred reflections. So 1 is a completely rough surface. And again, we can control the color of reflections to achieve different results. We can also use level. 0 means 0% of color, and 1 means 100% of color. We can of course choose colorful reflections as well. You can choose any color you need. Now, going back to roughness, we can also use glossiness, which was used in the original Corona material, and we can change it in the advanced options. Sometimes you will have glossiness maps, and this is when you can use this option. The rules are the same, however they work exactly opposite. So 0 creates totally matte material, and 1 gives sharp reflections. We can go back to the default settings here. You can see that we have IR disabled, which I'll explain later. It's because we're in the metal mode, so the value is automatically set to a really high value, and we don't have to worry about it. Now we have bump here and we can use a map, which I'll also explain later. In metal material, we can also add edge color that determines the metal reflection color for rays hitting the object at a grazing angle. Then we have anisotropy of glossy reflection highlights. To turn the effect on, we have to use a value different than 0. As we turn the effect, we'll enable rotation automatically. By changing the value, we can change the direction of the anisotropic highlights. Don't worry about this at this stage. I just want you to know that it's here. Translucency and refractions are disabled here as we don't have such combinations in nature. Now let's talk about non-metal materials. Let's change the mode. In the case of the non-metal materials, color is the diffuse color, so the color of the material. It is not a reflection color, like in metal materials. We can change this to any color we want. There are endless possibilities. And roughness works the same as in the metal materials. The higher the value, the more blurred the reflections. I said something bluish. Now IOR, so the index of refraction. It's specific to each material and you can check it online if you want the exact values. You can set the values from 1 to 3. As an example, value 1.52 is good for generic glass, but you don't have to worry so much about this at this stage. We can add bump, the same as in the metal materials, but the edge color is disabled for non-metals. We can also set the anisotropy, but I don't really use it in non-metal materials. However, in the non-metal materials, we also have refractions and we control if the materials are solid or transparent. Let's change the color to black. Set roughness to 0, for instance, so we have sharp reflections now. And set refractions to 1. We just created a clear glass. 0 means no transparency, so solid material like plastic, for example, and 1 means fully transparent material like clear glass. Everything in between creates a semi-transparent effect. By increasing the roughness, we can create frosted glass. Okay, so you can see that we have lots of control. Now, let's set some blue color, for instance, and I'll explain to you the bump. I use the noise map to show you how it works. Similarly as materials, all the maps are here. We plug the maps into the slots. Let me plug it to the diffuse slot for a moment so we clearly see how it works. So now, the map is working instead of the blue color. This is how we do patterns on materials. The scale of the noise map is too big and we cannot see it clearly. I reduce the size value. Okay, now I unplug it so we can focus on the bump. Bump maps simulate geometry changes based on the image. The light and dark values of an image imply height. It basically tells the 3D software two things: black is going down and white is going up. This is an old method though, and nowadays we mainly use normal maps, which I'll show you in a bit. First, let's talk about the displacement. Displacement maps, in contrast to bump maps, actually change the geometry of the mesh based on the image. Similarly as with a bump, black means the geometry go down and white makes it go up. We can control the strength of displacement here. Max values push the geometry outside, while minimum values inside the geometry. Another method of applying the displacement map is adding the modifier. It works similarly, however, it's dedicated to the object, and it doesn't work on everything that applies the particular material. You can see that now the effect is changing only on the bust. Okay, Let's go back to the normal map. I used one of the maps from Reload from the working files as an example. So normal maps are more advanced than bump maps because except from the height values of a texture, they can show angle as well. This allows them to show detail more realistically. So whenever you can, always use the normal maps. We cannot plug this map the same way as the bump map. We have to plug the Corona normal map first. It's needed if you want to load RGB normal map to use as a bump map for your material. There are various standards when it comes to the way normal map information is stored and interpreted by various 3D software. For that reason, in this case, we have to add Gamma to input. Now, the map looks good. Anyway, when you plug the map into the base bump slot, you'll see some changes in the objects. We can make the effect stronger by changing the strength multiply value. We can also control it here. Now we can use various textures for all of these slots. For example, we can use another map, the checker. Plug it into the base roughness slot. In this case, white parts of the map will make the object rough, and black areas will make the object smooth. If we plug it into base IR, the rule will be similar. An opacity map is a graphical representation of data where individual values are represented by transparency. White means an opaque effect, and black represents full transparency. Anything in between will create a semi-transparent effect. You can plug various maps into slots and get very different results, but the foundation is the same. And finally, let me present to you the translucency. The easiest way to understand how it works is to turn on the flashlight on your mobile and cover it with your finger. The finger is not transparent, but you can see light. You can observe the same effect when you fold the curtains a couple of times. You cannot see the things behind the curtains, but you still see the light. The same effect you can see on the plant's leaves. We have to turn on the thin shell first, which stimulates the thin shell with no internal volume. We can control the effect by changing the fraction value. 0 means no effect, and 1 means full effect. We can also determine the color of translucency. At the end, let me show you how we can control the maps. I changed the color of the noise map to make it easy for you to see the changes. And the size as well. Now, if we scroll down, you can see the Maps Options tab. Here we can turn off the map, so even if it's plugged, it doesn't affect the material. We also have the amount value. It allows us to blend the texture with the constant color. The value 0 means that 100% of the color is used. So at this moment, the objects are green as our diffuse color. If we go back to 100, it will take 100% of the map. Anything in between will mixes them together in different proportions. It will work the same for other maps. Okay, so these are the basics. We'll practice materials in the course, so don't worry if this is a bit overwhelming to you. We'll get there.